There we are. We're live. Hello. It's Tuesday, September 29th, and this is the third installment of USENIX's LISA Conversations. I'm Lee Damon, Senior Computing Specialist at the University of Washington.
Hello, and I'm your co-host, Tom Lumincelli. I'm a Site Reliability Engineer at StackOverflow.com. Each month, LISA Conversations brings you a speaker from a past USENIX LISA conference to discuss their presentation and find out, hey, what's new?
If you're watching live, we'd love to have your questions. You can submit them using the Q&A button. You might need to click on the 3x3 box in the upper corner of the Hangout to find it. It's usually in the upper right corner, but sometimes it moves.
So in this episode, we'll be talking with Dan Klein from Google. Dan gave a talk at LISA 2014 titled Making Push on Green a Reality, Issues and Actions Involved in Maintaining a Production Service. Dan, welcome to the podcast.
Thank you very much.
So we always open with these three questions. First, a quick softball warm-up question. Tell us about what you do at Google.
I'm currently a software engineer in catalog infrastructure, which means we take the assorted component parts of the shopping catalog and make it available so you can use Google Shopping.
And I assume your position has changed based on the fact that your title has changed.
Indeed it has. I was a site reliability engineer in payments when I gave the talk, and now I'm a software engineer in catalog infrastructure.
Welcome. Glad you're here. Always happy to have you as a conversationalist.
Thank you.
Let's start off with a high level. What was your talk about?
The talk was about making push on green a reality, and all of the things that you as a software developer, site reliability engineer, ops person, whatever testing person need to do to make it possible for you to develop a system, have the tests go green, and have pushes be automatic. But the talk was a lot more complicated than that because although the simple concept of build software, make sure it works, go, is easy to say, the various pieces that you need to add to your development process, testing process, monitoring process, rollout process is rather complicated. And I wanted to give people an idea about how they could do it themselves.
And do you have any updates or new things you want to say since the presentation?
The example that I gave of a system still that can use push on green still stands. There have been a number of developments in the industry in general, and because I'm talking about the talk that I gave last year, I'm not really at liberty to reveal new things that are going on inside of Google. But the basic tenet of test, monitor, label your rollouts, all of that still stands and will be true for quite a long time.
So why don't we back up just a little bit, and we like to assume that everyone watched the talk, but for the one or two people that might not have, let me just recap and then ask some questions. The software delivery process is coders, developers write code, it gets compiled, packaged, runs through a bunch of tests. In a lot of systems, this is automated, so every time they check in a change, all those tests happen. And then now, usually, any environment I've been in, that gets pushed into some beta environment. But before the beta software goes to the live, like what customers actually see, there's some committee of people that stand around, the 5 people, they stand around in robes and they officially bless the software before it can go into production. So what you're talking about in your presentation was replacing those people in robes with automation, which sounds crazy and risky, and that's what made your presentation so interesting.
It can be crazy and it can be risky, but it changes the definition, if you change the definition of what green means, then you can make things more automated. So your concept of the guys in robes blessing the release can still exist. At some point, there's nothing wrong with having a human in the loop that says this is okay. The human in the loop could be early in the development process. It could be a release candidate vetter who says that this candidate looks reasonable because it's passed all the tests. It can be an automated set of smoke tests that say, hey, the system behaves according to all the tests we've developed. It can be a regression test arbiter, or it can simply be that the build is good, go. And when you have any green condition, then you can release. The idea is whatever the arbiter is, and I presented all of these in the talk, when the arbiter, be it human or machine, decides that the system is ready to go, you push the new system. And if everything goes as planned, then you repeat the process over and over again. And there may be the chance of rolling back, but you push forward for each new version. Now, what you're describing is the scary process of somebody builds something and go, and somebody builds something and go. And at some level, that's the ideal, where you release early, you release often, and you're not afraid to recognize and roll back from your failures. So if something screws up, you just take it back.
And that's where the phrase green comes from. Some people might not be familiar with that.
Green is a green build because the software compiled and passed all the tests. Or green is a green build because the guys in robes said, you know, this is okay and we can go ahead and do the thing that we want. Or green is something which ran in the development environment for some period of time with some golden input data and passed all the regression tests, or any of a number of varieties. But green is, this is good, it's ready to go.
So in the dashboard, failures are red and success is green. So when the whole dashboard is green, you have that confidence.
Yes, that's the basic synopsis.
Sure. And I don't mean to fanboy this talk too much, but here's what I think is really radical about the talk, is that, you know, I use the term scary, like the scary, you know, push to production before, but this takes something that is scary, and because you have this really formal methodology, and I'd like to hear more details about that in a bit, but because you have this great methodology with the testing and the other things, the cultural stuff that you have developers go through and stuff, this sounds like it becomes less risky than what the typical sysadmin goes through in any given day, right? I mean, and that's what's so cool.
I agree that it's less scary because of a number of factors. Here is, let's pick an arbitrary tool, SendMail version N, and I'm currently running SendMail version K. Now, if I'm running version M, then I know that N is the next version, and chances are it's going to work. But if I'm not up to date, what changed? What am I going to have to do? I have to make a leap of faith to go from K to N. It's still a leap of faith to go from M to N because I don't know what's going on, and I don't know who developed it, and I don't know what their tests are, but a whole bunch of other people upgraded, and so it's probably okay. And that's a scary situation. One of the things that I mentioned in my talk is I'm running a rather antique version of BSD because I got lazy, and now there's so much updating to do that I'm just not going to be bothered. When my machine melts, I'll build a new one, but until then, it's just not worth upgrading because I'm so far behind and it's too scary. There are too many things that can break.
Mm. Right, that's what Stephen Markowski and others call the small batches principle.
Yeah.
I've been in environments, different environments, and one in particular, we did upgrades every 6 months, and that was so scary because of that means there were 1 million bugs fixed and features added in those 5.9 months before we got to the rollout. And this, and actually this is something I wanted to ask. So do you, so you're pushing out, I mean, in the talk you said multiple times a day, which means there are a very small number of changes in each in each batch, right? Now,
Yeah.
how granular is it? Is it because the people at Etsy talk about they push out into production after every single code commit, and some people say, well, that's that's a lot. We do it daily, and that's so much better than once every 6 months or whatever. What's the granularity?
Well, let me address the first question. More often is, in general, better than less often because of the fright factor. The other side of that is if you go for every release, then you go back to the early days of Linux where it was the operating system of the hour club, and any one of those releases could break something. So if you've got a production environment, you don't just want to blindly update. But it's perfectly reasonable to blindly update in your test or development environment. And every code commit can go ahead and cause a new rollout to happen. So this brings into mind then what are your environments. You have a production environment, you have a sandbox or development environment, you have a testing environment, you have individual tests. The granularity of rollouts can vary between them. So that for your testing environment, sure, push everything that goes. And in the development environment, push with a lesser granularity. And maybe for Sandbox, here is a vetted release, because now there's a human in the loop. Let's try this one. And then for the production release, after all of our tests work, let's go ahead and finally push to production. Because you want to make sure that what is user-facing is as safe as possible. In development, if it breaks, who cares? You can rebuild the development environment. In Sandbox, there's more cost because it's using more live data, but you still don't care as much as you care for if production goes down. So you want to grade when you do your pushes based on what the risk is.
So we have a QA question that's related to what you just said. Adrian Colley asks, what can you do about releases which contain a bug that survives automated testing but falls over as soon as it receives realistic traffic?
Well, the easy answer is you roll back. And that's the whole thing about being willing to recognize, accept, and act on a failure. If you, and this goes back to the first thing that Tom touched on, which was culture. One of the things that has to be part of your development system is a culture of engineers who are willing to do the following things. And before I start on that, when we talk about a sysadmin, they're not part of the culture. They're not part of the development environment. They are simply given a new release and have to trust that it's good. But when you have development engineers and testing engineers and site reliability engineers all working with the same mindset and same culture, then everybody trusts each other because they can communicate and they know what's going on. So to make that work, your developers have to develop code and have it peer-reviewed before it can be submitted. They have to write tests that have to be peer-reviewed before they can be submitted. When that happens, then you have a much greater certainty that the code that's being put into production is sound. But then you also need to have monitoring that checks whether the latencies and input and output ratios and so on are sound. And then you have to have site reliability engineers who are willing to recognize those symptoms and say, I don't like the way this smells, roll it back. And know that they're not going to catch flack from the developers or the testers because they've acted on their best instincts with the knowledge that everything should have worked, but it still doesn't smell right. And
so the number of people you've just described is great for a large site. What about smaller sites?
You still need to do the same level of checking and verifications, even if there are only 2 people. Somebody has to write the code, and then the other guy looks at it and says, this looks sane. Somebody writes a test, and the other guy, or girl, or, sorry, woman, droid, whatever, looks at the code and says, yeah, that test looks sane. Or says, I see you're testing for this success case, and this success case, and I see the code raises an exception when there's a problem. I'd like you to write a test that causes that problem to occur so I can verify that the exception is raised. You need to have cross-checking of your work. And even in a 2-person shop, you can do that.
So this is, I mean, doing code reviews is kind of newish. Well, so not newish. I think it's rare in the industry, and I think it's great that you're encouraging it. Would you say that it's really a requirement for a continuous deployment environment like, or just it's just what Google does?
Yes. I think, well, it is what Google does. Code doesn't get submitted unless it's been peer reviewed. And the peer reviewers are licensed to push back and say, no, I'm not going to approve this until you fix this. And therefore, the quality of the code stays high. But it should be a requirement for any continuous deployment environment. And in fact, it should be a requirement for any shop that is developing code.
I agree. I just haven't been able to convince my coworkers where I am. So
I can lend you my Cluebat, and you can work very hard with it.
So
didn't you write the book that's full of the Cluebats?
Let's change the subject. So you were saying you were talking about sites that are well, let's talk about how we can apply this to sites that are smaller than Google. Let's count how many of those would be. 1, 2. Okay, let's say a lot. What would you recommend if I was at a small site, which I am, and wanted to do this? What would you recommend people do that are just getting started? Like, what are some of the baby steps that they might do to get into this?
Well, one of the things I mentioned at the start of my talk is that my target audience is somebody who's running a production service on one or more machines and with one or more development environments. So you can do this on a single machine. It's a little riskier because you're testing production, but it's still possible. You should have more than one development environment, but if you want to push to prod every time you make a change, it'll still work. The first baby step is test everything. Make unit tests, make end-to-end tests. And in the talk, I mentioned Heartbleed, which was an exploit of a vulnerability in OpenSSL. And if you look at the OpenSSL code, there are hundreds of modules, and there are 5, 10, a dozen tests of the system. And they test, can you make an SSL connection? Can you make a different SSL connection? Can you send encrypted data? And those are useful, but there is this mathematical module which takes an input and produces an output, and I don't know what it's for, and I can't see any place that tests it. It's in the middle of a stream, so that if I make a change to that module and all of the end-to-end tests work, did I introduce a vulnerability? I don't know. There's no test for the module. Does the module pass or fail? I don't know. There are no tests for the module. So you have to write tests for everything, and that means for every module, but also ideally for every function within that module. And you make tests that verify that things pass and that things fail when they're supposed to in the way that you expect. And then, go ahead.
Sorry to interrupt. So you're saying the first step is just to get to the point where you're doing CI, continuous integration, and then evolve over time more and more tests.
And when you say continuous integration, what I'm talking about is just part of the build process, so that if anybody changes any module or any routine, you rerun the same tests, and those tests all should pass. Then you've done it right.
Sure, and I think a lot of companies do that. There's everything from Jenkins Hudson and TeamCity is a commercial project. And there's a lot of testing frameworks out there, for different languages and at the application layer. So then,
but that's what happens when you find that bug that makes it all the way through. You find the data that caused the bug. You write a test that exhibits a failure case. Then you fix the code and make sure that the failure case is now properly detected by the tests.
Right. Those are the regression tests you were talking about in the talk. So if anytime a failure gets through the system, you write a test for that explicit thing, so that if you see that same problem in the future, it gets caught?
Well, sort of. If we discover what the root cause of the failure is, then you write a test which exhibits that failure. Then you fix the code and make sure that the failure doesn't get detected by the test because it no longer exists. So the test should fail with the bug in place, but with the fix in place, the test will now pass. And I'm talking more about test-driven development. Write the test before you write the fix to the code.
Sure, sure.
So that's the first thing you need to do. Get in that mindset of building modular code which is testable and tested. Then the second thing you want to do is get in the habit of monitoring your code. And that means putting in inline monitoring and not just saying, oh, the website's working, because that's an end-to-end test. You want to be able to try an input and verify that there's an output and do that automatically, yes. But you also want to look at latencies and timings and throughput and other indicators of your system so that you can see when you submit a new version, are there changes in those indicators? And if there are changes, why? We just sped things up. Oh, look, we have more throughput. Well, that's great. But do you also have the same data coming out on the other end? You need both of those tests.
So Adrian asks another question that's relevant to this. How important is it to have a staging environment for simulating a production release after green but before push? I don't remember actually hearing you talk about that, aside from Canary, I guess, would be the staging environment?
Canary is sort of the final stage in pushing to prod. So when I mentioned multiple environments, staging or sandbox or devel are different ways of looking at the same problem. It's not your production environment, but it's close enough to your production environment. And you can have n levels of stuff. You can have just a production environment. That's not the best way. You can have production and staging. You can have production, staging, development, test, sandbox, whatever you want to call them. The more you have, the more throughput you can have because you have different levels of testing and verification along the way. And if you do a release for every software change, then you may only need 2 or perhaps 3 environments, one for testing, one for just before it gets released and then push to release. But yes, it's important to have a staging environment. When I talked about canaries, I was talking about if you have the luxury of having multiple jobs running, all doing the same thing with a load balancer in the front, then update some small number of them and have the load balancer send some amount of traffic to the new binary so that you can look at the new binaries running in production with real traffic. If there's any problem, you turn off those canary jobs, and the load balancer will adjust automatically saying, well, the canaries are down, keep sending it to the old version of code. But if the canaries look good, then you can update the remainder of the job. So canarying is different than a staging environment. It's a staging in prod environment, if you would.
Tom, did you want to ask the next question?
Sure.
Bad one?
Well, actually, I wanted to take a detour away from the talk, the technology specifically. Something that you mentioned in the talk and just before is you're still running BSD 4.8 at home. You said.
It's up to 5.3.
5.3. Okay.
Yeah.
You want so you're up to the last. You're only what 5 or 10 years out of date.
Yeah, I'm only 10 years out of date.
Okay. So so how long have you been a BSD user?
Since 2.1.
Fantastic.
And I knew the
for the young kids, you should explain what 2.1 means.
That means it's really old, and we had a computer with one CPU.
That means it was before Linux.
Yeah, and it was a
home
VGA
audience.
monitor, and it was old.
But you probably weren't running that at home because that ran on like big $50,000 VAXs.
Well, are you talking FreeBSD 2.0 or 2.1, or are you talking BSD 2.1?
I'm talking BSDI 2.0. 2.0 actually, I think, is the first one that I ran. The
Right, so
distribution came on a floppy.
what was the first Unix you encountered?
Version 5.
See, there you go, Tom. That was
By
the
the way,
question you were trying to ask.
not System 5. System 5 came after System 3, which came after whatever, and then you go back to version BSD 4.2, 4.0, version 7, version 6, version 5. I encountered it in 1976.
It's
Okay,
an
so
exciting
you're kind of a
part of
noob.
history.
I understand that. I'll try to go easy on you.
Yeah, that's okay.
So actually, I have something you mentioned in your talk about flags. I want to talk about flags for a moment.
Okay.
So my first question about it is, you say you shouldn't be running with thousands of flags, and honestly, I completely agree with you. How many times a year do you actually do audits? Go back and say, do we need this flag? Do we need this flag? Should this flag go away? Is this an option that we should still have?
It's not something that I can quantify as an N times a year thing, but it should be fairly regular. What I talked about was the development process for enabling a new feature. So for those of you who haven't seen the original talk, if you want to add in a new feature, the safest way to do it is to make it flag switchable so that you can have the canaries with it and other jobs not, and you can enable it for this locale or not that locale, or in this country or not that country. Any of a number of things are possible. So the process of adding a flag is rather complicated. First you add the flag, which does nothing, and then you add a configuration file that has the flag in its default off state, and then you turn the flag on, and then you get rid of the flag wrapping the code, and then you get rid of the flag in the config file, and so on. And that process is part of the normal development cycle of a flag-based feature. Now, there are many ways of doing flags, but the entire process should be designed around putting the flag in so that you can enable a feature, so that you can then have that feature be default, so that you can get rid of the flag.
So as a sysadmin, I live in a world of too much entropy. I mean, my job is to fight entropy.
Right.
And one of the things I find is stuff gets abandoned and forgotten.
Right.
So that's why I'm asking about, do you actually go back and do audits to say, hey, we never finished this. This flag should go away. This bit of the code should go away, or is your process so perfect that you never have to do that?
Why? Of course I'm perfect. The reality is that sometimes flags do get forgotten, as they will in any place. Entropy is a real problem for everybody, but if you, as with testing, build in the mindset of these are the steps that I'm going to do, then when the thing becomes live, it is in your mind that in the next release or two, you're going to start decommissioning the flags. And so we try to minimize entropy by maintaining the mindset of this is the normal way of doing things. Now, as I said, there are many ways of having flag-based systems, but if your normal mindset is start, middle, end, then you're heading towards the end all the time. And sometimes you go start, oh no, forget it. But if you're always heading towards the end, then the flags tend to go away on their own. Entropy does exist. There are people who go, what the hell is this for? And then it goes away. But if it's a third party doing analysis of why is a feature present when there's no perceptible need for it, then you've got to poll a lot more people as to why it was originally there and what was its original function and can we disable it and what are the effects of it and so on. And in a system where there's turnover, that institutional knowledge can easily get lost and then you've got to rebuild it. So having somebody do flag audits is useful and necessary, but much more difficult than having the mindset of install a flag, get it working, get rid of the flag because it's now the default behavior.
So when you file the bug or feature request that says, we need to add foo, do you also file like a child ticket that says remove the flag and forward date that out or something? Because personally, I am in awe that you remember to come back and remove the flags.
I actually put calendar entries in to remind me to remove flags.
That's one way of doing it. Another way is with tracking bugs, where you have a bunch of steps. There are checklist systems. There are the equivalent of Gantt chart systems. There are a number of ways of ensuring that you do that. And sometimes the event horizon that you're looking for is 6 months. So perhaps your test engineers or your release engineers are tracking those features. Somebody's got to keep track, yes, and it may not be the developer. It may be the tech lead or the test engineers hitting you over the head saying, you forgot to get rid of this. And then you go, no, I didn't. I just forgot to file the bug or whatever. But yeah, somebody's got to keep track, and mechanical aids help a lot.
I'd like to take a moment to remind those people watching us, thank you again for joining us. The Q&A question and answer option is available to you. Please do take advantage of it. You may need to click on the 3x3 grid in the upper right corner of this display in order to do it, and we encourage your questions. Tom, back to you.
Oh, well, so another interesting, I guess this is a cultural as much as technological thing that you raised in the talk was about, it seems that Google has well, part of the hygiene of keeping the system healthy is always be deprecating old technology and getting rid of it. I've been in, well, a friend of mine has an environment that, has that one CentOS 5 machine left, and, the amount of labor for that one machine makes you want to just, you could be just buying the person a new machine, but they refuse to upgrade their operating system. It seems that, like, you hinted that Google's really good at that, and it sounded like there are people that it's their job to go around and deprecate old hardware or make sure that those last stragglers got out. Did I misinterpret what you were saying?
I honestly don't know about who has those interesting jobs of destroying racks, but there is
libraries and stuff.
There is certainly an effort in the software development to make sure that we get rid of cruft. And if cruft is old, obsolete libraries and there is a new one that is available, it just seems like it's a natural part of the process for any organization to stay current.
Oh, I so wish that were the case.
I so wish that it were the case too, because as you have said, entropy is very strong. But when you have this is one of the advantages of Google. We have hit a critical mass where things get done because it's the right thing to do. And with a small organization, the right thing to do is stay afloat. And the only way you stay afloat is by patching. And I appreciate that in a one-person shop, that may be the way to deal. But as soon as you exceed half a dozen people, then you have a culture. And the culture is one of cross-checking and reinforcing and shared knowledge and individual searching for knowledge. Each person winds up with their specialty, and they're the go-to person for a particular concept or idea, and they are the one that you talk to about what's the latest graphic library that I should be using, for example. And they're the one that realize that, okay, it's libpng and no longer libjpeg, and you're really using libgif? Okay, we need to throw that out and change things. Once you have a culture of mutual support, then the entire process becomes so much easier, because now you're not competing. You're all following the same goal. And I know I'm sounding very socialist and rah-rah, let's wave the flag, but really it works.
Well, it sounds like you also have management support, and something, since Lee mentioned my books, something that I recommend is management has to pick how many old versions of libraries or hardware or whatever are we going to support, and if it's if we're going to support 2 generations in production, or 3 or 100, whatever it is, management has to enforce that. And if you have, if you say we're going to have 2 in production at any given time, that means when a third generation comes out, you can't let those people launch that new version until the last of the N-2 generations is out. And I think if the people that really want to launch their stuff have the responsibility to deprecate the old stuff, then it has 2 benefits. One is they're motivated because they're not happy unless their stuff gets launched, so they're motivated to get that last straggler off. And also, in theory, they have the expertise to help people convert to the newest stuff. And it forces them to talk to their customers, which I didn't think about it until just now, but that alone is a good exercise.
And sometimes it's a case of being willing to deliver bad news. So I don't work in Android. I don't know how it works, but I do know that I have a really old phone that is running a really old version of the Android operating system, and the new version just isn't supported on it. So I can still make phone calls, and I can still pull up a incredibly crappy version of Maps, but I'm not going to get any new upgrades. And the Android team is willing to deliver the bad news of, you've got an old phone, we're not supporting it anymore. And that's sometimes necessary to do. That, yep, this is old and tough. So you can still run Windows 95, but you're not going to get any updates to it.
Right. So that's more of a carrot than stick philosophy.
Right. You can still use it. It's just not going to get upgraded. So it's both a carrot and a stick. But it requires that somebody be willing to deliver the bad news of, this is end of life.
Mm-hmm, mm-hmm.
And sometimes it's not that somebody be willing to, it's that somebody be empowered to.
Yes.
I work in research in a university. I can go to a PI and say, hey, you know that computer that you love so dearly that you paid a lot of money for 10 years ago? Maybe it's time for us to take it out of the rack and put a newer machine in. I have one PI who actually listens when I say that, and one now former PI that I no longer work for who did not. My reality is I can't force that ticket. I cannot go to them and say, you have to do it. The machine dies eventually, and that's when I get to replace it. So not every shop has the feature set of being able to say, yeah, we're going to keep current. Sometimes you have to deal with the hardware you've got.
And I have $100,000 worth of garbage in my basement, literally. I have a Cisco 2621 that is my main router, and now I have 2 warm spares because a friend of mine said, I don't need these anymore. They cost $200. Here, it's yours. But the first one I bought cost me $4,000 or $5,000 from DoveBit. And I've got a Livingston firewall router, which cost me $3,000, and now I think I have to pay you to take it.
Right. This sounds like a cultural issue, and really it comes from management. I mean, in a university environment, management doesn't have the power to make those pronouncements. But in the corporate world, there's more flexibility and more of the ability for management to, management needs to not only say, we're going to have 2 generations limit, but enforce it and also fund it, because it's not free to deprecate old technology. And it sounds like Google has that is just ingrained in their culture, and management understands and supports that, which is great. I mean, I've been at companies where one department decided, well, this year we're going to save money by going from 2 generations in production to 3 generations. And I was like, wait a minute, that's saving money, this month
right.
on paper. And in one case they said, well, yeah, it's going to cost the company overall, but that expense is going to be paid for by the IT department, and that's not our budget, so win for us. So
complexity can be very expensive.
Right. So it's not just a corporate culture and a management thing. It's it's not just a corporate culture of being smart about managing your generations, but it's a corporate culture of doing what's best for the company instead of local optimizations that solve your particular problem.
And here's the other thing. At Google, at least, managers are technical. They're not just managers. They understand and use and often help build the technology so that when they're making informed decisions, they truly are informed decisions. Mm-hmm. They're not arbitrary, and they understand what the technical components are. And that's part of buy-in. You get buy-in from management from the process because they understand the process.
Mm-hmm. So how would you recommend people deal with management that isn't technical when this exact problem happens?
Well, the optimist in me says educate them, but that means that you need to get their time and their ear, and I know how difficult that can be. So you hire the right managers, and this is, again, a cultural thing. Where I work, it starts from the top down, where the culture is imbued into new hires, and it percolates from the bottom up, so that the technology is transmitted and the technological decisions are suffused throughout the entire organization. But if you have I shouldn't say gray hair because of my own, but if you have a starchy, technophobic management in a technological company who is making decisions based on old information and an unwillingness to change, then I think the best change you can make is find a different job.
Dan, do companies like that exist? Sorry, just kidding.
With the starchy people who are
with managers that are technophobic.
Yes, I worked for a banking firm in New Jersey where I did management consulting for a while, and there were these little walled fiefdoms where people simply did not talk to each other because they were on different teams and they might steal our land.
Sure.
That's far too common, unfortunately.
Yes.
Yeah.
So we do have another QA question that I'd like to get to. It's actually going back a bit. It's about flags again. And I'm going to read it verbatim. It's a fairly long question, so prepare yourself. The Google flag dance sounds like a Google-specific problem. If you get the runtime configuration from etcd, Zookeeper, Chubby, DNS, instead of flags, then what's wrong with rolling out a feature to 100% and leaving it there indefinitely? This is another question from Adrian, who seems to be the only one using the QA system. Hint, hint.
Well, thank you, Adrian. Why is the flag there is the first question that I would ask. What purpose does it serve? As you say, the Google flag dance is used at Google because what we're doing is, in the example that I gave in the talk, rolling out a new feature which is expected to be used everywhere once it has been rolled out. So the example I gave is you want to enable in a payment system pay by Bitcoin. Eventually, you want pay by Bitcoin to be enabled everywhere. And so there's no need for a flag because you don't want in your code to say, if pay by Bitcoin, do this, else do that. You simply want to say, well, pay by Bitcoin is enabled, just do the code. So you want to get rid of the guards in your code, which make your code more readable, because you don't have to, as a reader of code trying to figure out what you're doing, determine, is this enabled or is this not, and what are the ramifications of it being here or not. You simply want to read straight line code and say, I'm going to do this, there's the Bitcoin code, here's the PayPal code, here's the Google Wallet code. We do all of the things that are necessary, and there are no conditionals that we have to work around. If, on the other hand, a flag is of the sort where some people are going to use it and some people aren't, so let's say I'm releasing a new version of Linux and I want to say that I want to use the old-style mouse tracker, which is going to move 1 inch at a time. And let's say that's a feature that half the world wants, and the other half of the world wants it to be 2.54 centimeters at a time, or whatever the conversion factor is. And you have one half of the world wants one feature and one half of the world wants the other feature. That's where you have a flag. But if everybody's going to get a feature, you don't want a flag because you don't want to have to read the code and figure out what's going on. So your example of putting something into a config file and leaving it there forever is fine if some fraction of the world is going to have a different value for the flag in that same config file. But if everybody's going to have the same value, why have a configuration flag?
As long as it's well documented.
And that last, so something I didn't understand when I was looking at the talk until later was what the whole flag flip dance was like 6 steps or something, and
some large number, and I forget.
And when I looked at it, I thought, oh, I could optimize this. I could remove that one step, and then I realized the step I was optimizing was really a precaution against what if there's one configuration file out there that still lists the flag.
Right.
And so, yeah, so it was interesting to see all the, yeah.
The reason for the complexity of the dance is to minimize the number of things that can go wrong across each step. Yes, you can put in the flag, run the code, get rid of the flag. And you can do that, but the safest way is to do the complicated dance because then the minimum number of things breaks between each step in the dance. And so, the ability to localize where the problem is increases.
So I guess your answer to Adrian is you could shrink it to a fewer number of steps if you, depending on how much risk or how much confidence you have that you've eliminated the flag. And he's saying it with Zookeeper, if everything's in Zookeeper, you can be assured that you've eliminated the flag if all your services, if the only way to set a flag is put it in Zookeeper.
So I'm not familiar with Zookeeper.
It's like Chubby.
It's like what?
It's an open source clone of Chubby.
Okay.
What is Chubby?
Chubby is a...
What I am, I need to lose weight.
It's a... I will give an explanation that computer scientists would hate, but it is a way of having flags and configurations distributed globally transactionally safe. So it's either everyone sees the same flag or no one gets the update.
So anyway, what I heard Adrian asking is why, if you have a flag, do you not just set it and forget it? And the answer to that was, if you set it and forget it, then why is it set? Why isn't it the default behavior? But if you have different settings in different environments permanently, then that's a good reason for having a flag, because you want one environment or one machine or one user or one country or whatever to behave differently than a different set. That's where you have the flag. But if everybody has exactly the same setting, why have a flag? Get rid of the conditional code, because it only obscures the intent of what your code does. Yes, it works just the same, but the more of those you have, the harder it is to read your code. And the harder it is to read, the harder it is to maintain. And
so it becomes a code maintenance issue.
Yes.
That's how I read it to begin with, yeah. So I'm going to kind of go a little more meta here. I know that Google is a huge organization, and that it's, saying does Google do is kind of a ridiculous question, but I'm going to do it anyway. Does Google do this kind of flag dance for all of its projects and services, or are there other groups that do other things?
What I said in the talk, and the reason I'm weasel wording you this way, is that the talk that I gave is what was cleared for release, and I can't really give new things. So what I said...
I wasn't asking you to describe other... I was just asking a yes or no question.
Right. What I said in the talk, and the answer is yes, what I said in the talk is there are a number of ways of doing configuration changes. And the flag dance is one way of doing it, and there are others which are used at Google also. Yes.
Cool.
But if you have flag-based code, then what I was trying to show is the safe way of making changes. And the reason for doing that is to show that, yeah, there are a lot of steps in getting push on green to work. And if you are meticulous about following them, then you are as safe as you possibly can be. When you start shortcutting things and saying, well, I just want to change one thing, I don't need to run the tests again, that's when all hell breaks loose.
That's when you're there until 2 in the morning on Saturday morning.
Right.
Right. I believe in the talk you said that you were the first or one of the first projects at Google to use push on green. Can you talk about how pervasive
The
it's
flavor
become?
that we were using, the particular flavor that we were describing is one of the groups that was, sorry, we were one of the groups that was using that particular flavor, but I don't think I said we were one of the first.
Okay. So how pervasive is this?
Certainly Google's been around long enough that a number of different ways of managing this kind of system must exist.
Mm-hmm.
And as to how pervasive it is, I don't know. But it's the goal of all production teams to make things work as smoothly as possible and as automated as possible so that we don't have user-facing outages.
Mm-hmm. Mm-hmm.
So I realize you're constrained in what you can talk about, but I did want to follow up on your issues for the future slide, where you mentioned rollback feasibility, continuous delivery, rollout quotas, and green on green. Can you give us an update on any of that?
The answer is no, but only because I left the team shortly after the paper was delivered. So I don't know what they've done. I'm working in a completely different area now.
Okay.
I know that they were goals when I left, but I don't know how much of it's been
done. Shall we?
Last call for Q&A, I think. Let's see if there's any more. Well, there's no more Q&A questions, and I think this is a good time to go into the close anyway.
Yeah, I do want to ask. Dan, I've been going to Lisa for a long time, and I believe I told you, I don't know, a year or two ago. I remember meeting you at my first ever USENIX event. So you've been going a lot longer than I've been going.
1980. 1980.
1980. Yeah. So my first was, I believe, 89. So what are you looking forward to at Lisa this year?
You know, the reason I keep going to the conferences is the hall talk. There are always interesting papers, and I don't know what the papers are because I haven't looked at the program. I don't even know if the program is available. I just go because I know there will be interesting papers, but there's also fascinating hall talk, and that's the main reason that I keep going, that I can share information that I have and save somebody a ton of work, and I can talk about a problem that I'm having, and somebody just walking by will hear and say, oh, have you looked at this? And suddenly I've got 5 hours of web searching solved for me in 30 seconds. It's just that endemic character of the conference, which is the dissemination and distribution of information that you are expert in and somebody else isn't, and vice versa. That's why I go, and that's what I look forward to every time.
Awesome, awesome. And since we're talking about Lisa, I just want to make a quick plug to people that are listening live. There's a one-day, I guess, mini conference, or I can't remember the exact term, but the Container Summit, the one-day summit on container management is. The schedule has just been announced on the website, so we'll put the URL for that in the show notes. I guess, as Lee said, it's time to start wrapping it up. So, Lee, why don't you start with our closing questions?
Okay, closing questions. Dan, you ready for these challenging? This is our Actors Studio closing questions series here. You ready?
Rapid fire.
Rapid fire. So, question number 1: what was your personal first computer?
You mean that I owned?
Mm-hmm.
Yeah, and we'll add also what was the first one you used.
First one I used was a PDP-8E. It had 4K of memory and supported 4 simultaneous users, and I have no idea how they did that. The first one that I owned, I think, was a Mac SE, but prior to that, I had borrowed friends' Macintoshes and Hackintoshes and Frankintoshes and so on.
Question number 2: have you ever gotten to press the big red switch, that is the emergency power off button, for a server room or DC?
I didn't get to press the power off, but I did get to start a multi-megawatt diesel generator. And one of the cool things about that is, A, you have to wear double hearing protection. So you wear earplugs and earmuffs, and there are certain places you don't want to stand because occasionally rats will get in, and they like living in places that, when you start the diesel motor, throw out steaming bits of flaming rat.
Former ratness.
Yes, former ratness.
So, question number 3. Who's your favorite computer scientist or author?
Favorite author, I have to say, with great sadness, is Terry Pratchett. He's a brilliant was a brilliant satirist, and I am slowly and lovingly working my way through Crown and the Chalk, which is his last book.
Awesome, awesome.
I've read 35 or 40 of his books.
Great choices. Well, hey, Dan, this has been wonderful. I want to thank you so much for joining us.
Well, thank you.
So that brings us to the end of this month's LISA conversation. We hope you enjoyed it. Thanks to Julie from USENIX for all the backstage work, to our live listeners for their questions, and to our guest Dan Klein from Google for joining us. Please join us on October 27th when our guest will be Sabrina Farmer. We'll be discussing her WIAC 2012 talk, Overcoming My Biggest Roadblock, Myself. Check the LISA Conversations website for details.
And also join us at the next USENIX LISA conference. Watching these recorded videos is fun, but nothing compares to being at the conference itself. The next LISA is November 8th through 13th, 2015 in Washington, D.C. The schedule information is published, and you can register right now on the website. Early bird discount expires in a few weeks, so get to it quickly. We hope to see you there.
I'll be at least feel free to ask me questions or tell me about cool things I don't know.
That goes for all of us, actually.
Yes.
I look forward to talking to people there. It's one of my main fun things. Grants for women and students are still available. For information, please go to, and I'm going to rattle off a string, but Julie will add this to the show notes. It'll be in the doobly-doo later on. https://www.usenix.org/conference/students-and-grants. Did you catch that? Did you write it down? Don't worry, it'll be in the doobly-doo.
And that's grants for women and students. Yes. So this is Tom Limoncelli.
And this is Lee Damon. Thanks for joining us, and we'll see you next month.